Welcome to the DIY Honda Garage channel. Welcome to this detailed diagnostic analysis focusing on DTC P050D, which stands for Cold Start Idle Speed Problem. This error applies to the Honda CRV models from 2017 to 2022. A cold start issue can manifest in situations where the vehicle struggles to maintain idle speed after starting, especially in cold environments. It's crucial to address this issue promptly, as it can affect engine performance and fuel efficiency. The PGM-FI, or Programmed Fuel Injection System, plays a vital role in regulating the air and fuel mixture for optimal combustion. Understanding the core components involved in this DTC, including the IAT, or Intake Air Temperature Sensor, CKP, or Crankshaft Position Sensor, and MAF, or Mass Airflow Sensor, is essential for effective troubleshooting. Let's explore these components and the overall process for resolution. DTC P050D specifically indicates a cold start idle speed problem within the PGM-FI system. This system is responsible for the proper delivery of air and fuel to the engine, ensuring optimal combustion. The primary components involved include the intake air temperature, IAT sensor, which measures the temperature of the incoming air, and the mass airflow, MAF sensor, which assesses the amount of air entering the engine. Both of these sensors are located in the engine's intake air duct before the throttle body. Incorrect readings can lead to improper fuel mixture, causing idle instability during cold starts. These components must be verified to determine if they are operating within their specified ranges, directly impacting the vehicle's performance during initial starts. The possible causes for a P050D error code can vary widely, often encompassing several sensor malfunctions or connection issues. A faulty MAF or IAT sensor can provide erroneous readings, leading to improper air-fuel mixture specifically during cold starts. It's crucial to inspect both sensors closely. Additionally, poor or loose connections in these circuits may lead to intermittent failures, preventing proper sensor functioning. Another likely issue is a dirty air cleaner element. If debris accumulates, it can obstruct airflow, further complicating the mixture needed for optimal starting conditions. Each of these components must be evaluated to accurately pinpoint the cause to move forward in rectifying the issue effectively. Symptoms associated with DTC P050D primarily revolve around difficulties during the initial cold starts. Drivers may notice a rough idle, where the engine fails to maintain a consistent speed, or may even stall entirely. This behavior is concerning, as it indicates that the engine is struggling to achieve the necessary operational conditions. Additionally, the illumination of the check engine light serves as an alert that a malfunction has been detected within the PGM-FI system. This warning indicates that there is likely a need for immediate diagnostics and repairs to restore normal engine functionality. It's important for owners to address these symptoms promptly to avoid further complications down the line. In the first troubleshooting step for resolving DTC P050D, the technician must turn the vehicle to the on mode. This action ensures that the vehicle's electrical systems, including the engine control module, are powered and ready for diagnostics. Once the vehicle is on, check for any pending or confirmed DTCs using the Honda Diagnostic System, HDS. It's crucial to identify if there are any other error codes indicated. This information can provide insight into additional underlying issues. If other DTCs are present, they must be addressed first, as they may directly affect the cold start idle performance. This initial diagnosis sets the stage for subsequent troubleshooting actions. The second troubleshooting step involves a visual inspection of the intake air duct. The intake air duct plays a critical role in delivering air to the engine, especially during the starting phase. Inspect for any poor connections, blockages, or damage that might restrict airflow. If the duct appears compromised, it may need to be reconnected, repaired, or replaced entirely. Ensuring this component is intact is vital for the correct functioning of the PGM-FI system and can directly impact the idle performance during cold starts. If everything looks okay, the technician can then proceed to the next step to further diagnose the issue. The third step in diagnosing DTC P050D involves inspecting the air cleaner housing. The air cleaner housing encases the air cleaner element and is essential for filtering incoming air. A visual check is necessary to identify any connections that may be loose or any blockage that could impede airflow. If any issues are found during this inspection, the air cleaner housing could require replacement to ensure optimal air supply to the engine. An unobstructed air path is crucial for the proper functioning of the engine and, by extension, the PGM-FI system. If the air cleaner housing checks out, the next step involves examining the air cleaner element itself. In this fourth troubleshooting step, we focus on the air cleaner element. The air cleaner element filters dust and debris from the incoming air, impacting the quality of the air that reaches the engine for combustion. Inspect the air cleaner element for dirt or debris accumulation. If it's found to be dirty, it is imperative to replace it immediately, as a clean air filter is vital for maintaining optimal airflow. A dirty air cleaner can result in restricted airflow and poor engine performance, which is particularly detrimental when the engine is cold. If the air cleaner element is clean, the next step is to verify the operational parameters of the engine once it cools down. Step 5 requires the technician to cool the engine to a temperature of 122 degrees Fahrenheit or 50 degrees Celsius or less before proceeding. At this temperature, the engine represents a cold start condition, which is essential for evaluating the cold start idle issue accurately. Once the engine is cooled, use the HDS to clear the DTC from memory. After clearing, start the engine and allow it to idle for at least 10 seconds, monitoring how it behaves at cold start. This real-world observation can provide valuable data on whether the issue persists. It's critical to note the OBD status with the HDS. A failed result indicates the problem still exists, necessitating further investigation. The sixth troubleshooting step centers on verifying the performance of the mass airflow (MAF) sensor. Start the engine and hold the engine speed at 3,000 RPM without load to enable simulation of operating conditions. Monitoring the MAF sensor through the HDS, check that the readings fall between the expected thresholds of 4.1 to 5.7 grams per second, G/. This check ensures that the MAF sensor is accurately measuring the air intake. If the readings match the threshold, the sensor is functioning correctly, and you can continue to the next step. However, if it fails to meet the specified parameters, replacing the MAF sensor or IAT sensor is necessary to resolve the cold start idle issue effectively. The final troubleshooting step involves evaluating the IAT sensor performance. To begin, turn the vehicle to the off mode and allow the engine to cool until it reaches ambient temperature. Note the current ambient temperature. Afterward, turn the vehicle back to on and quickly record the IAT sensor's reading with the HDS. If the IAT sensor's reading varies by 5.4 degrees Fahrenheit, 3 degrees Celsius, or more from the ambient temperature, replacing the MAF IAT sensor is crucial. If the IAT sensor appears functional, check for possible obstructions, dirt, or carbon buildup in the throttle body. Cleaning or addressing any damage can drastically improve cold start conditions. It is essential to wrap up the process by ensuring all involved components are functioning accurately. In the final repair verification phase, it is essential to ensure that all connections and components checked during troubleshooting are secure and functioning correctly. A successful repair relies on the integrity of these connections, as loose or poor connections can reintroduce the cold start idle speed problem. If necessary, utilize the HDS to clear any remaining DTCs from the system once repairs have been conducted. After confirming that all components related to the PGM-FI system are operating effectively, perform a final idle test to validate that the cold start issue has been resolved. Pay attention to how the engine behaves during cold starts, ensuring that the idle remains stable without fluctuations. Preventive maintenance is crucial for avoiding issues related to DTC P050D in the future. Regularly inspecting sensors, including the MAF and IAT, can significantly reduce the likelihood of cold start idle issues. Consider scheduling routine diagnostics that check for fault codes as part of general vehicle upkeep. Additionally, cleaning the air intake system periodically helps maintain optimal airflow to the engine, preventing carbon buildup, dirt accumulation, and blockages. Replacing the air cleaner element according to the manufacturer's recommendation is another excellent preventive measure. Keeping these maintenance aspects in mind will ensure the reliability and longevity of your Honda CRV. In summary, addressing the DTC P050D involves a thorough understanding of related components such as the MAF and IAT sensors, as well as the air intake system. Symptoms like rough idling and engine stalling during cold starts indicate a more profound issue with these components. Following a meticulous troubleshooting process ensures that all potential causes are examined and rectified. The importance of timely diagnostics cannot be overstated. Resolving these issues early on prevents further complications and maintains the vehicle's long-term performance. Being proactive with preventive maintenance practices will contribute significantly to keeping your Honda CRV running smoothly. Thank you for your time and attention, and drive safely. Please like and subscribe to the channel. See you next time.